Hello. This is Tulani Kelvin, the tutor. Today we are doing physical science for grade 11. I'm going to focus under physics, which is paper one. I'm going to do examples from the question paper for 2015. So we are going to focus on how to resolve the vectors and also to determine the resultant and as well as the direction of that resultant force. So without any waste of time, let me just start. So on question 2, I was given a sketch there or a diagram. So they say three forces PQR of magnitude 500 newtons, 200 newtons, and 300 newtons respectively act on a point O in the directions shown in the diagram below. And they say they are not drawn according to scalar. So there are two methods to determine the resultant. It's either you are going to use the calculations or you are just going to do the construction and then use the scalar there that you are given 10 millimeters is equals to 50 newtons. So well, I'm not going to use I'm not going to sketch, you understand? I'm not going to do the construction and measurements. I'm just going to use calculations because of I think it's easier when we use calculations. So I'm just going to copy this diagram into the board so that it's going to be easy so that we can work it out. So 2.1, they say refer to the information in the diagram above and give the reason why forces PQR are classified as vectors. So vectors, they have magnitude and the direction. So you can see it has the magnitude and as well as the direction pointing to the north east. So therefore you can simply say that. Moving forward, they say determine the magnitude and the direction of the resultant either by calculation or by accurate construction and measurement. Use the scalar, blah blah blah. So I'm using a calculation like I said. So let me copy this into the board. So there is my sketch. Now I have to determine the resultant. So before I can determine the resultant, I have to start by resolving my vectors there or my forces. So let me just start with P and yeah, PQR. I will just start like that. So when we resolve the force of P, you can see that P basically we don't have angle for P, which is from this horizontal line or the x axis. So therefore what I'm going to do, we know that let me use a different marker. Here we are having a 90 degrees because of this is perpendicular with the horizontal, therefore meaning that we have 90 here and then this angle is 80. What we can do, we can simply say that this angle over here is going to be 80. You understand? Here we are going to have 80, which is going in this direction because of when I add these angles together it must give me 90. So 30 plus 80. Oops, I think I'm doing a mistake here. I'm sorry. I'm doing a mistake. Sorry. Let me just try to erase here. Though they are going to mess my things. It's not 80. Automatically, I'm having 60 here. Is 60, guys. I'm sorry about that. You know, it's Sunday in the morning. We having the sun is out. It's not cloudy like yesterday. So well, like I said, we are having a 90 degrees here. So therefore, meaning that when we add these angles, we must make sure that we get 90 degrees. So what I can do, I can just say 90 minus the 10 minus 30, and therefore you can simply punch on your calculator. So when you say 90. Yeah, when you say 90, oh, what's going on here? 90 minus 10 minus 30, you get your your answer is 50 degrees. What is wrong with me today? Maybe I'm tired or something, because I keep on doing mistakes, and this is automatically wrong. Well, here we are going to have 50 degrees. When you add this and this is 80, and therefore is 90, meaning that the angle that the angle for P, well, the angle for P is 80. It's 80 degrees, because we are going to add basically we are going to add 50 plus 30, therefore it's going to give us 80 degrees. That's the first thing. Before we can resolve, we have to determine the angle there, you understand? Make sure that our angle is correct, and therefore we can simply go to resolve and determine the resultant. So therefore I'm going to start with the horizontal component. I'm just going to use HC there to represent horizontal components. So therefore when I use the okay, or either way you can use f of x there if you want to use it. Means that the forces that are on the horizontal, but I prefer to use horizontal component HC, or you can write it in full horizontal components. So therefore when we construct the for P there, when we construct for P, we are just going to have something like this, and then we are going to have another one like that. So people sometimes they find it difficult to determine the directions of this the forces that act on the let me say the horizontal component, and as well as the vertical component, to determine their direction. So when we resolve, guys, we follow the direction of this resultant force. This is the resultant force, you understand? So therefore we are just going to follow this, meaning our horizontal component is going to face that way, in that direction, and then the vertical component is going to be like that. Remember, the angle that is acting here is 80 degrees. Therefore when it's 80 degrees, you remember for the horizontal component, we are just going to say 500 newtons, and then the cos of 80, therefore we are done for P. For the horizontal, we will come for the vertical. This is only for the horizontal, you understand? Now I'm focusing on Q. So okay, I guess you understand me. But I thought maybe I should label this, but I think you understand me the way how I explain these things. Therefore we come for Q, we are having, let me use a black marker for Q. Well, for Q we have to resolve, meaning that the vertical component is also going to be like that, and then the horizontal is going to face in that direction. Therefore what is going to happen, we are having a 200 newtons. There is going to be 200 newtons. The cos of 30, the angle was given there. It's simple, we don't have to determine the angle. And then therefore moving forward, we go to let me use a red marker. Well, I have to resolve again. So therefore when I resolve, we are going to have a force that is going in that direction, which is the horizontal force, and the vertical force will go in that direction. The direction is important, guys. You must know how to resolve your forces. You must make sure that you know how to resolve your forces before you do mistakes, because if you miss a mistake, you are going to have a problem. Here is 30 degrees. The degrees there, I think it seems like a 0. Yeah, it's 30 degrees. Make sure you don't do any mistakes. Moving forward, we have to, let me just write for, okay, let me use a red marker. This is for R, is 300 newtons. The cos of 60. So the cos of 60. So now this is the form. I can say this is the formula for the horizontal component, and therefore I can simply punch my calculator right now. You can also punch your calculator as well to make sure that I don't do mistakes, you know. So when I punch on my calculator, I get my answer is 410,03 newtons. I just rounded off to 2 decimal places. So this is the answer for the horizontal. Now we have to determine the vertical components. The vertical components. So, well, the vertical components, I can say we can use it as f of y, meaning is the forces that act on the vertical day. Therefore, now we can just set up the equation for the vertical components. So I will start with P. Let me use a blue mark again. Therefore, when I start with P, for the vertical is going to be 500 the sine of 80. Without looking at the sketch, you can simply take it from here, and then here is going to be 200 the sine of 30, and then for I'm sorry for not using a different marker, but I guess you understand, or let me just use it for the sake that you understand. Okay, here is going to be 200 the cos of 30, I mean the sine, you remember is for, this is the vertical components, right? So it's going to be the sine of 30, and therefore on this one is going to be 300 the sine of 60. So this is simple, guys. This is simple. It's not difficult. You just need practice, and then you'll find it correct if you're struggling to determine the resultant, you know. So therefore, moving forward, you just have to punch on your calculator. So therefore, I get my answer is 852,21 when we round it off to 2 decimal places. This is newtons. So therefore, that you can see that this is the vertical component, meaning that is going in the upwards direction is important, since is positive upwards, and therefore this one is for the vertical, therefore it's going to the right. You must make sure that you represent your directions there, because we are dealing with vectors, you understand. So therefore we have the sum for the horizontal and the sum for the vertical components, and therefore what we can do, I can simply represent it by, if this, let me start with the horizontal, therefore is going to the right. Well, I'm just going to represent it using a line that is going to the right. Therefore, I can simply say is 410.03 newtons. And then for this horizontal, since it's going in the upwards direction, therefore I can simply represent it with the line that is facing to the north there, or upwards. 0.2, yeah, doesn't matter if you don't see it, the value is right here. It's newtons as well, and therefore we have to determine the direction, but we have to determine the direction and the resultant now, because of we having the sum of the vertical and as well as the sum of the horizontal. So therefore this is R, guys, which means is the resultant, or let me use a capital letter R so that you can see. So we can use the theorem of Pythagoras from here to determine the value for, or the sum of the resultant there for these forces, these three forces that are acting on this system here. So therefore, if we use theorem of Pythagoras, you know, I'm just going to say R is equal to the root of I'm not going to write the The formula for this, I guess you know that from mathematics. So therefore, it's going to be 410.03 squared plus the value there 852.21 squared, and then therefore you can easily punch on your calculator, you'll get your resultant there. So when I punch this on a calculator, I get my answer is 940 45,72 to two decimal places, remember. So this is the resultant. This is the resultant that they were asking, but we are not done yet. We have to determine the direction of the resultant. So therefore, when we determine the direction of the resultant, let me just make some space because the board is full here. So when we determine the direction, I will just remove this. I hope you're taking notes, or you can just rewind, you can go back, and if you didn't take notes, take notes. So therefore, when we determine the direction of the resultant, we are going to use the trig ratios, because we will determine the size of theta there, or whatever angle that you want to put there. Therefore, we are having the opposite here, and as well as the adjacent. That was the hypotenuse. Remember, we already got the value for the hypotenuse, and therefore I'm just going to use tan here. So when I use tan is opposite. Opposite is 852,21 over the adjacent, which is 410. And you can just do the inverse there. The inverse of tan is going to be something like this. Therefore, is 852,21 over 410.03, and then you just punch on your calculator. So the size of theta, or the direction of this, is going to be 64.31 degrees. Therefore, this is the magnitude, and as well as the direction for the resultant. This is easy as it is, guys. You have to just determine it there, and then you are done. You are done with your calculations. This is how easy you can do it, guys, whenever you encounter such problems in the exam, because of this is how you should do it. So that was it for question 2. Therefore, moving forward, I'm just going to go for the next question. I think the next question it's supposed to be, it's Newton's. That's where Newton's second law starts here. So let's just jump into question 3. So they say a constant force F pulls a 50 kg block at a constant speed over a rough horizontal surface. A rough horizontal surface. This means that there's a friction that is present there, and they say AB is shown in the diagram below, meaning that the force that is pulling this 50 kg block is just from A to B there, you understand? And therefore, the coefficient of the kinetic friction, mu k, between the block and the surface is 0.4. So we are given the coefficient of the kinetic friction we have in the block, which is 50 kg. We don't have the force, but the force is acting at the angle of 20 degrees there. And they say draw a labeled free body diagram to show all the forces acting on the block. So if we let me just draw this. Let me draw it, middling the board. So in question 3, we are having something like this. Okay, let me just check again. It's 20 degrees 50 kg. Okay, 20 degrees, this is 50 kg, and then the force there is F, and here is A, and this is B. This is a horizontal, I mean, this is the rough surface, you know. Yeah, it's also in the horizontal. So therefore, let's just go back. They want a labeled free body diagram, so it's easy on the horizontal. It's easy. So a free body diagram for this, let me just start with a dot here, a dot. I like to draw a bigger dot so that my forces can be clear, you know, when I draw my free body diagram. So I'll just start with the normal force. Let me just say f of n there, and then I'm having fg there, which is for the mass, and then I also have this force is pulled towards direction to B, meaning that the friction is acting on the opposite direction. Here we are just going to have f of k, and then therefore moving forward they are having the force which is acting at the angle. We can simply represent it like that, and they say this is the force applied, Fa. So this is how you can draw your free body diagram, you understand? So moving forward, let's just move on. So they say state the Newton's second law of motion in ways. Well, I'm not going to state that for you guys. You just have to go and study it in the book. Make sure that you memorize it in your own way. Make sure that when you go to the exam you don't forget. So they say that moving forward, 3.3 calculate the magnitude of F. They want the force that is applied there, the magnitude of F. So for the magnitude of F, yeah, let's just go and calculate that magnitude of F. And then we are given the coefficient of the friction between the surface and the block, which is 0.4. Okay, 0.4. We're having mu k as 0.4, and they want the force that is applied here. So in order for us to calculate the force, we have to resolve this force because of its acting at the angle of 20 degrees, meaning that if we resolve, we are going to have a vertical component which is going to go in that direction, and as well as the horizontal force which is going to go in that direction. Let me just write my arrows properly. So we are having the angle there, so the formula for the horizontal is just going to be the force applied, the cos of 20, and therefore for the vertical is going to be the force applied, the sine of 20, you understand? And therefore they want this F, you remember the force applied, so we are just going to use the second law of motion, Newton's second law of motion. I think we are just going to use yeah, the second law of motion, right? So we can simply say F net is equal to MA. Therefore, for F net is equals to MA, we just have to break this. We just have to break this F net here. So therefore, when we have when we have to break this F net, we are just going to look at the forces that they are acting on for the horizontal only, and ignore for the vertical forces, because of they want the force applied, and the force applied is acting on the horizontal. So therefore, if you can just look at this, we're having the frictional force which is on the negative. Let me take this side as negative and this side as positive, you know. So the F of k is negative there, and then moving forward we're having uh, the force applied is on the right is positive plus the nope, not the force applied, man. The horizontal force. You remember we did resolve this force since it was acting on the angle. Is going to be the cos of 30 there is equals to the ma, which is the mass and the acceleration. So therefore we are given the coefficient of the of the kinetic friction. So let me just go to the formula sheet. Let me go to the formula sheet so that I can show you the correct. You are given some the formulas, guys, in your exam, you know. So for forces, which means this is the formulas that we are going to use. Those are the equations of motion. Yeah, and then they do label these equations. It's easy for you, you know. So and then we also have some constants there. Maybe they might help, but in this case they are not going to help. They are just going to help in, you know, in the next lessons, you know. So this is the formula just that I just used is F net is equals to the mass and times the acceleration. And then this is the formula for friction. We can use this formula for friction where they say mu k is equals to f of k and the normal force there. So it was mu k is equals to the f of k over the normal force. So if we have to just do the subject of the formula, f of k is just going to be mu k and n multiplied by the n there, which is the normal force. And therefore in this case we know that the normal force the normal force is equals to the fg or the weight. Let me say weight, you understand? And then what we have to do, we're just going to take 50 multiplied by the gravitational force, which is 90.9.8. We're also given it in your formula sheet. Here is it. Where is the gravitational force? The gravitational force is just right here. Acceleration due to the gravity or the gravitational force is 9.8. Just know that. And then therefore, so in this case, you can see that the normal force is not only the normal force which is acting towards upwards. We also having the horizontal force for the force applied. You understand? So therefore, our meaning that our formula in this case is going to be the Fn plus the Fa, the sine of 20 is equal to Fg is just 50 multiplied by what is 50 multiplied by the 9.8 there. So therefore I'm just doing the formula for friction. Don't get confused. So this is the normal force there, and therefore what I'm just going to do, I'm just going to multiply these values here. Understand? So 50 multiplied by 9.8 is just 490, and I transpose this one Fa minus sine of 20 is just going to be negative, and my normal force is this one. Therefore is 490 minus the force applied minus the force applied multiplied by the sine of 20. So for the friction we have in the normal force now, and then we can simply say is negative, remember, negative 450 minus the sine of 20. So multiply by the multiplied by this. So let me just, here I will use the square brackets and use the common brackets inside here to represent the multiplication is 0.4. And moving forward, we are done with the friction. Let me close my square brackets and plus FA, the cos of 30 is equals to, the mass is 50 kg and times A. So let me just go back to my statement and refer what I was given. Let me just, a constant force F pulls a 50 kg block at a constant speed over a rough horizontal surface AB, shown in the diagram below. The coefficient of friction between the blocks and the surface is 0.4, and then they state that, so we are not given the friction there. So we are not given the acceleration. I wonder what's going on here. Let me just go to the board and see what's the next step. Well, it's just a long procedure because of, you can see that is 6 marks. So what is happening here, since they said this is on the horizontal, you understand? I mean, it's on the horizontal here, and it's moving at a constant speed. So the constant speed is going to be 0. There's you understand, 50 multiplied by the 0, the acceleration is just going to be 0 there. So I will just erase this, guys. I guess you did take the notes how I got this. You understand? I will just erase now. So meaning that our acceleration is going to be, I mean, yeah, it's going to be 0 since is on the constant, is moving at the constant. We are just going to have 0 there, and when we have to simplify here, I'm just going to multiply this by 0.4. You understand? It's going to be 0.4 multiplied by 450. So 0.4 by 490 is 450 or 490. It was 450, 490. Okay, it's 450. Well, like I wrote on the board. Well, I'm not sure with that value. It's negative there. Since I'm removing the square brackets, I can use the common brackets. It's 180. So, and then when I multiply the sine of 20 by 0.4, sine of 20 by 0.4, 0.4, I get my answer as negative of 0.14, the force applied, FA there, and therefore this is going to be plus. I can simply now, get the answer for cos 30. So cos 30, if you punch it on your calculator, you will get your answer as, I'm using the decimals, is 0.87, 0.87, the force applied. Let me write my 0 just here, just to trying to be neat. And now I have to just, you can see that we are having the force applied here, the force applied, so we can see that we are just reaching our conclusion. It's 190 plus 0.4 FA plus 0.87, the force applied there is equal to 0, and therefore you can add these two since they are the like terms, you can see, and then is just going to be 0.14 plus 0.87. Therefore, you're just going to get your answer as 1. Get your answer as 1,01 when you round it off to 2 decimal places and you transpose that one to the other side, is going to be positive 180, and then you can simply divide it by the answer there, which you divide it by 1.01 there, and then therefore let me see your answer. I get my FA, my force applied, as 178.92 newtons. So this is my force applied now. This is my force applied. So it was a long procedure because of you had to, do the formula for or calculate the friction and then resolve. That's why it was 6 marks, I understand. But as long as you know how to resolve, you apply the concept, it's going to be easy for you, you understand. It's just going to be easy, guys. All you need to do is to practice, and therefore, yeah, you'll be better with your physical sciences, my especially paper 1, because of most of the learners, they say it's difficult, so moving forward, we have to determine or calculate the magnitude of the normal force, so when we determine the magnitude of the normal force, so when we have to determine the magnitude of the normal force, let me just erase here. Okay, let me just write this value here. The normal force, now we know the FA is 178.92 newtons there. It's positive, therefore it's to the right, yeah, I won't need anything here again, so let me just erase. So now we have to determine the normal force. We could use this formula, but we don't have the friction. We don't know the value of the friction. We only have the coefficient of the friction. So therefore, what I'm going to use, I'm going to, the normal force. The normal force is equal to Fg, you understand? And Fg, well, is equals to the W, you understand? Well, what I'm going to do now, the normal force is not only the normal force which is going in the upwards direction, we also having the vertical component of the force applied there. Since the negative there, it affects everything in your system, you understand? So it's going to be the normal force plus FA sine 20 and plus what again, the 50 times 9.8, the gravitational force, understand? And therefore you just have to substitute your values here. We don't have the normal, is the one we are looking for, and the force applied is 178.92 sine of 20. Oops, what am I doing? Oh my fucking god. Plus 50 times 9.8 there. Therefore, you just punch on your calculator, or you can easily transpose that one to the other side. It's all up to you, you know. So, answer sine of 20. So, the answer for this one is 61.19, okay? And then, therefore, is the normal force plus, you can just press the other one, the 50 times 9.8 is 490. Is 490. There, I think I made a mistake. Did I use 490? Well, if I didn't, guys, just make sure that the same procedure that I did is the correct procedure. Maybe I did a mistake when I had to, you know, because I'm alone here. There's nobody who is helping me, understand? So you'll find explaining, doing the calculations, punching the calculator is a mess, you understand? It's messing with my head. Well, let me just continue with these values. If I did a mistake there, you can just go and rectify it, you know. Simply rectify it and then just substitute the values there, and then it's going to be easy, because of the most important thing is to resolve your formulas. If you know how to resolve your formulas and substitute the values that you are given, it's going to be easy. Therefore, if I transpose this one to the other side, I'm getting my normal force as 428.81 newtons. It's positive, it's going upwards, you can say upwards, you understand, because we are dealing with vectors, they need direction and blah blah stuff, you understand. So you can say upwards there, but we all know that the normal force is always going to go upwards, you understand. So this is the normal force, and then let's just go and check for the next question. Oops, I'm sorry, what am I doing? Okay, so now they want the frictional force, you understand. So you have to determine the force applied, the normal force, the frictional force. If you get the normal force, the force applied wrong, therefore you won't get the next questions correct, you know. Is the follow-up question here. This was a follow-up question. So moving forward, when we determine the frictional force, when we have to determine the frictional force, let me just write my value of the Fn there here at the top, because I will need the space. It's 428.81 newtons. 408.81 is 81 newtons. Okay, let me just do the space here. Now they want the frictional force. We already had the kinetic friction. We already had the formula there, so it's going to be easy. These are follow-up questions. So this is the formula, mu k and the normal force. So we have everything. Mu k is 0.4 multiplied by 428 by 81. 0.81, and then therefore you just have to punch on your calculator. Okay, your answer is, the frictional force is just 171.552 newtons. You can say left, because it's the frictional force, you understand, the left. Make sure that just to put yourself on the safe side, guys, just write the directions, you understand. You are dealing with vectors here. Vector is a quantity of what? Direction and the magnitude. Make sure that you do that. So that was the value of the friction, and then was the next question, and therefore yeah, you are done, you understand. And they say 3.6, they say the same constant force F is now applied to the block over the same rough horizontal surface as before, but in the direction shown, meaning that at first it was like this, at and then now they change how they apply. They were pulling it, and now they push it. You understand? At this angle, so they say give a reason why the block will move slower than before. So they want to know why the block will move slower. So here the normal force will increase, hence the frictional force will increase, and that's why the block will be harder to move, you understand? Because of the frictional force, it will be increased, and then the normal force, you understand? So that was it for today, guys. I did teach you how to resolve the forces, determine the resultant force, and as well as the magnitude, as well as the direction. And also we did Newton's second law of motion, how to apply it, how to resolve the forces. Well, I believe in the next video we are just going to do Newton's second law, where the forces are in the incline. You have to resolve, you understand, just master the horizontal, and therefore on the incline is just going to be easy for you guys, you understand? Because of time, I don't have enough time. I wish I could do that, but I don't have enough time. So we will meet on the next video. So guys, don't forget to subscribe into the channel. There is the tutors Facebook page, like it, is tutors, so you will get information there at Facebook, the notes, the link of the videos, different videos, so make sure that you just like the page so that you can get the notifications. Subscribe to my YouTube channel so that you can get the latest updates for you know so, and also don't forget to share these videos to your friends, family members, classmates, just for recommendation. So I hope this video was useful for you. You did understand. I did try my best to understand. If you have any question, you can directly post it on Facebook, and then unfortunately I don't provide my email address here, you understand, because of I don't feel like providing it. I only allow learners to ask questions at Facebook there, you understand, at Facebook, or you can just comment on the video on at YouTube there. Yeah, we will answer you, you understand. So thank you for your time.